Good morning, students. Yesterday we have studied what is bond fission. Bond fission is the breaking of bonds. It is of two types: homolytic bond fission and heterolytic bond fission. Homolytic bond fission means equal breaking of bond. As a result of homolytic bond fission, free radicals are formed. Then secondly we have studied heterolytic bond fission. Unequal breaking of bond is known as heterolytic bond fission. As a result of heterolytic bond fission, ions are formed. Ions means charged particles. So yesterday we have studied these topics. Now today we will study bond angle, bond length and bond energy. So what is bond length? Distance between the nucleus of two bonded atoms is known as bond length. Then next we will see the examples of bond length. Then bond angle. The angle formed by directions of two covalent bonds in which three atoms are bonded by two covalent bonds. The angle formed is known as bond angle. So examples of bond angle also we will see. Then bond energy. So bond energy we have two types. Bond if the diatomic molecule is there, then we will say that bond dissociation energy and bond formation energy are same. But for polyatomic molecules, the bond dissociation energy and bond formation energy are not same. And the bond dissociation energy for all the bonds, when they break, we have to take the average of each bond, and that is known as average bond energy. So here we will consider the average bond energy and we will see the examples of bond energy values. Now we will start with bond length. Bond characteristic: bond length, bond angle, bond energy. Bond length, it is also called as bond distance. The distance between the nuclei of two bonded atoms through a covalent bond is called bond length. So this is the nucleus, is the atom, hydrogen atom. This is another hydrogen atom and this is the nucleus of hydrogen atom. The distance between these two nuclei is known as bond length. What is bond length? The distance between the nuclei of two atoms bond through a covalent bond. When they are bonding to a covalent bond, the distance between the nuclei of two atoms is known as bond length. Examples of bond length. Hydrogen bond length is 0.74 angstrom. C-C bond length is 1.54 angstrom. We will see it angstrom. C-H bond length is 1.10 angstrom. C-O bond length is 1.41 angstrom. C-N bond length is 1.47 angstrom. These are the examples of bond length. So what is bond length? Bond length is the distance between the nuclei of two bonded atoms is known as bond length, and these are the examples of bond length. Next we will see the bond angle. Then next is the bond angle definition. The angle between the directions of two covalent bonds is known as the bond angle. So two covalent bonds are formed and three atoms are there and two covalent bonds are there. The angle formed is known as bond angle. Bond angles give an idea of the geometry and shape of the molecule as they depend on bond angle. So when we see the bond angle, we will know by seeing the bond angle we can say that what is the shape of the molecule, what is the geometry of the molecule, we can know by bond angle. For example, the methane molecule has H-C-H bond angle of 109 degrees 28 minutes. We will read it as 109 degrees 28. If comma is here, then we will say 28 minutes. Comma it is apostrophe like, then we will say 109 degrees 28 minutes. And it has tetrahedral shape. How is the bond? What is the shape of the molecule? Tetrahedral shape. By seeing the bond angle, we can say that it is having the tetrahedral shape. Examples of bond angle. So in the methane molecule, H-C-H bond angle is 109 degrees 28 minutes. So what is the bond angle? Angle formed by three atoms and two bonds. Three atoms and two bonds is known as bond angle. So here H-C-H, all the bond angles are same, 109 degrees 28 minutes. So we will say that when we say the bond angle, we have to mention the three atoms. H-C-H bond angle is 109 degrees 28 minutes. Next is ethylene molecule. In the ethylene molecule, H bond C dash C is 120 degrees. H dash C dash C is 120 degrees. So here all the bond angles is 120 degrees. Next here in acetylene molecule, C dash H bond angle is 180 degrees. H dash C bond angle is 180 degrees. So these are the examples of bond angle. Methane molecule, ethylene molecule and acetylene molecule. This you have to by heart the three bond angles. What is the bond angle? When the definition is asked, you have to give the examples and its bond angles. By seeing the bond angle, we will say that the molecule is a what is the shape of the molecule or what is the geometry of the molecule. Next, bond strength or bond energy. There are two measures of bond strength. They are bond dissociation energy denoted by D and average bond energy denoted by E. So what is bond dissociation energy? The energy required to break a particular bond in the gaseous phase to give free radicals in the gaseous phase is called the bond dissociation energy D. So H2 is a diatomic molecule. When the bond breaks, H dash H bond breaks, then the dissociation energy is 431.4 kilojoule per mole. The bond energy of H dash H bond in hydrogen molecule is 431.4 kg per mole. So it is a single bonded diatomic molecule. Hydrogen molecule is a single bonded diatomic molecule. The amount of energy required to break the bond are same, and it is also called bond. It is the same as it is bond formation energy. So bond dissociation energy and bond formation energy for hydrogen molecule, hydrogen-like molecule, diatomic molecules with a single bond is the and the bond formation energy are same. In polyatomic molecules, the amount of energy required to break individual bond is not same. So when the bond breaks CH4, so 4 bonds are there. When each bond breaks, the energy required is different, and hence bond energy in such molecule is defined as average bond here. In that cases, in polyatomic molecules, we are not taking bond dissociation. We are taking all the average of bond dissociation energy, and it will become average bond energy. Average bond energy. It is defined as the amount of energy required per mole to break a particular bond in a molecule in gaseous state, producing free atoms or radicals. So when the bond breaks, each bond break, we are taking the energies and we are taking the average of all that bonds, and that is the average bond energy. I have given here an example in next slide when we are how to calculate the average bond energy. In case of methane, the successive bond dissociation energy of C dash H bond differs from one another as given below. CH4, CH3H. So first C is having 4 hydrogen atoms. So when the first hydrogen atom breaks, then the bond dissociation energy is 439 kilojoule per mole. When the second bond breaks, the bond energy is 460 kilojoule per mole. And when the third bond breaks, it is 423 kJ per mole, and when the fourth bond breaks, it is 339 kilojoule per mole. Here D means dissociation energy. So in each case, all the dissociation energy you are seeing, they are different. All the dissociation energies are different, and here we have to take the average of 4 bonds. So average bond energy of C dash H bond in methane molecule is the average bond dissociation energy. Average bond energy of C dash H bond you are taking 439 plus 460 plus 423 plus 339, 1661 divided by 4. 4 bonds are there. So we are totaling all the dissociation energy divided by 4, because 4 bonds are breaking. We will divide it by 4 and it will become 415.25 kilojoule per mole. So if how many bonds are breaking, that many bonds you have to divide. Total energy divided by that many bonds, how many bonds are breaking. Then you will get the average bond energy. Examples of bond energy values. H dash H bond when it breaks, we are getting 104 kilocalories per mole. When C dash H bond breaks, 96 to 99 kilocalories per mole. When N dash H bond breaks, 93 kilocalories per mole. O dash H bond breaks, 110 to 111 kilocalories per mole. When carbon bond nitrogen breaks, it will get 69 to 75 kilocalories per mole. When C double bond C breaks, we are getting 146 to 151 kilocalorie per mole. When C double bond S bond breaks, we are getting 132 kilocalorie per mole. When C double bond O bond breaks, we are getting 173 to 181 kilocalorie per mole. So these are the examples of bond energy values. So we are seeing today we are seeing the bond length, bond angle and bond energy. Bond length is the distance between two bonded atoms is known as bond length. Bond angle is the angle formed by two bonds and three atoms is known as bond angle. And the bond energy, two type bond dissociation energy and average bond energy. When diatomic molecule is there, then you are taking bond dissociation energy, but when it is a polyatomic molecule, you are taking the average of all atoms and then all the bonds are breaking and you will take the average and it is known as average bond energy. And for diatomic molecules, bond dissociation energy and bond formation energy is same, but it is not in the case of average bond energy. So these are the topics today we have studied.